Okay, let's brute force SSH today. So I'm going to show you 3 different tools you can use to brute force SSH. Quick disclaimer, I'm doing this in a lab. If you do this without permission on someone else's machine, you could be fined or even do jail time. It's very illegal. So do this in a lab or do this with permission. Okay, first tool we're going to use is called Ncrack. Ncrack is made by the same people who made Nmap, and it can handle 12 protocols. That's including SSH, the protocol I'm going to show you right now. In testing, in lab testing, it's been kind of slow, around 24 seconds to brute force in this particular scenario. So let's jump right in. We'll go Ncrack, tac F, which stands for upon first valid username and password found, go ahead and exit. And then we're going to do -P, which stands for protocol and port. And in this case, it's going to be protocol SSH and port 22. Then we're going to go uppercase U, which stands for use this list of usernames. We're going to do uppercase P, which stands for use this list of passwords. Then we're going to do the IP address of our target, 192.168.229.129. Let's go ahead and let this run. I will cut out any dead space in the video to move things along. Okay, you can see here that it found a valid username and password, the username being Zerolag and the password being password1234. You can also see that it took 21 seconds to run. So let's clear that, and then really quick, let me show you the username list and the password list that we are using for this demonstration. So I'll go vi tac uppercase O, which stands for open a file vertically, and I'll put O2, which means open 2 files vertically, and then I'll give it the name of the files, if I can spell right, usernames.txt, passwords.txt. Good. Now here is the usernames that we're using for this test. Here's the passwords. Note it is going to try for every username, it's going to try every password. Now the valid username and password in this scenario is Zerolag and password1234. So those are the files we are dealing with. Okay, now on to the next tool, which is Medusa. Medusa is known for its robustness in handling services that don't always respond correctly to Hydra, which is the next tool I'm going to show you. Medusa can handle 17 protocols, including SSH. It's the slowest tool I'm going to show you today, clocking in around 50 seconds for this scenario. Let's jump right in. So I'm going to use the time command. The time command is not necessary to use with Medusa. It's just I'm using the time command because it'll output how long it takes for a particular command to run in Linux. So you can use the time command with any command. You can use it with grep, you can use it with ls, you can use it with find, anything. So if you are using Medusa in a lab, you can go ahead and start here where I start typing Medusa. Medusa uppercase U, which again stands for use this list of usernames. Uppercase P, which stands for use this list of passwords. And then we'll go tac F again, which again stands for exit upon first valid username and password found. And then we'll go tac H, which stands for target this host, which is 192.168.229.129 in this particular case. Then we'll go tac M, uppercase M, which stands for use this module. And in this particular scenario, we are using the SSH module. We'll go ahead and let this run, and then I'll cut any dead space out of the video. Okay, so coming back here, you can see that it found the correct user or a valid username and password here, Zerolag and password1234. It took approximately 49 seconds to run. So kind of slow. There are other options you can use with Medusa to speed things up a little bit, but out of box, it is the slowest performer of the 3 tools I'm showing you today. So let's go ahead and jump to the next tool, which is going to be Hydra. It's one of the favorites of pen testers. We'll jump right in. Hydra, tac L, which is like uppercase U for the other tools. So tac uppercase L, which stands for use this list of usernames. Uppercase P, which stands for use this list of passwords. Tac F, which stands for exit upon first valid username and password combination found. And then to give it the target, we're going to do things a little bit different with Hydra. We are going to give it SSH : because we're using the SSH protocol 192.168.229.129. Now, before I hit this, I forgot to tell you, Hydra's been around longer than Medusa. It works with 25 protocols, including SSH, and it is the fastest of the 3 tools that I'm showing you today. In this lab scenario, it usually takes around 7 seconds, but we'll see how long it takes when we run it this time. There it goes. All right, so this time it worked. Sometimes these tools have some hiccups. That's why there's other options, other tools you can use. So login, Zerolag, password 1234. This took, let's see, where 38, 210838, 210841. So that is 3 seconds. So as you can see, it's a lot faster than the other tools I've shown you today. So before we move on, let me show you another interesting little factoid. Okay, so if we open this is the target I'm on now. If we open the config file for SSHD config, you can see here, go down to line 35. Max auth tries equals 6. That means max authentication tries of 6. That means we can try to input a wrong password 6 different times before the username is locked out. So one of the defenses against brute forcing is to lower this from 6 down to, like, say 4 or 3. That is one of the defenses. Also, another defense for brute forcing is a typical best practice. Let me close this. Let me clear that screen because that's given me a OCD flare-up. So again, best practice to beat brute forcing, you can use certificates for login, a public and private key. I won't go into depth in this video about what public and private keys are, PKI is, because that's outside of the scope of this video. But basically, you need to have the correct private key that matches a public key on the server in order to log into the server. So another, oh, and you can also password protect the private key so that you're akin to double protected there. You can also lock down the SSH service to only accept traffic from specific IP addresses or hosts. That's another defense. Another defense is hardware tokens like YubiKeys. But before I start going down a rabbit trail on defenses, I just want to say that's it for today. If you work in the industry, little advice, don't let anyone talk down to you or make you feel small. We all started knowing nothing. It's no big deal. Imposter syndrome is real in this industry. But bear in mind that the guy at work that you look up to, that you think is so much smarter than you, has probably just had imposter syndrome a lot longer than you. So that's it for today. Thanks for hanging out. Have a good one.